So, have you heard the buzz? There's a giant rock hurtling through space, and it's headed for our galactic neighborhood. Let's dive right into this 5-minute guide on the massive asteroid that's about to make a close approach to Earth. Okay, let's get straight to the question that's probably on your mind. You hear plane-sized asteroid and approaching Earth in the same sentence, and you gotta wonder, is it time to worry? It's a totally fair question, especially with all the headlines out there. And I'm here to tell you the short answer is a big, clear, resounding no. We are perfectly safe. But the long answer, well, that's where things get really interesting. That's the why and the how, so let's get into it. All right, to really wrap our heads around what's happening, we've got to look at the numbers. Let's meet our cosmic visitor and break down its stats. First up, size. We're talking about an object that's about 180 feet across. Now, to put that into perspective for you, that's roughly the size of a commercial airplane. So, it's not going to end life as we know it, but it's definitely a pretty substantial chunk of rock. And what about its speed? Well, this thing is absolutely blazing through space at over 30,000 miles per hour. I mean, that is just fantastically fast, and it gives you a sense of the incredible power we're dealing with in these cosmic events. And here it is, the most important number of all. Its closest approach to us will be about 2.8 million miles. Now, that sounds like a crazy huge number, right? But what does that actually mean when you're talking about the vastness of space? And that really is the key question, isn't it? How close is close in cosmic terms? To really understand that 2.8 million miles, we've got to put it in perspective. First, just a quick definition for you. This object is what's called a near-Earth asteroid, or NEA. That's the official term for any rock whose orbit brings it into what scientists call Earth's neighborhood. It's basically a label that says, hey, we should keep an eye on this one. Okay, now this slide really tells the story. Look at that first bar. That's the distance to our own moon, right? About 238,000 miles away. Now, look at the second bar. That's the asteroid. The difference is just staggering when you see it like this. So here's the bottom line, the most important takeaway. When this asteroid is at its absolute closest point to us, it will still be more than 11 times farther away than our own moon. It's not just missing us, it's missing us by an enormous, enormous margin. So you might be thinking, if there's no danger, why is this even news? Well, that's because for scientists, this isn't a threat at all. It's an incredible scientific opportunity. Astronomers are actually really excited about this. And here's why it matters. Every safe flyby, like this one, helps astronomers get better at predicting asteroid paths. They can fine-tune their analysis of its size, its speed, and all that data feeds directly into something called planetary defense. Plus, hey, events like this get all of us looking up and thinking about our place in the universe, which is pretty cool. And that phrase right there, planetary defense, that's the key. This whole event is a perfect, real-world example of why we have these amazing systems in place constantly watching the skies for us. A flyby like this really shines a spotlight on the crucial work of groups like NASA's Planetary Defense Program. Their entire job is to find, track, and understand these near-Earth objects so we have a heads up, way in advance, if anything ever does pose a real threat. So let's just be crystal clear. This event is a safe flyby, happening millions of miles away, and it's an awesome chance for us to learn. A potential threat is a whole different ballgame, but this safe pass, it's the perfect reminder of exactly why we have to keep watching. You could even think of it as a great practice drill. And that really leaves us with this final big picture thought. We know this one was a safe pass. We tracked it, we understood it. The real question going forward is, how do we keep getting better at watching the skies for all the other